بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الاستاتيكا بعنوان مركز الثقل. طبعا مركز الثقل ده مهم جدا جدا. كل إنسان له مركز ثقل، كل جسم له مركز ثقل، الأرض لها مركز ثقل، كل جسم له مركز ثقل. والمركز الثقل ده فيه خط لابد ان هو يمر بمركز الثقل الارض ومركز الثقل الجسم اللي احنا عاوزين نعرفه. مهم جدا جدا عشان نعرف مدى جاذبية الارض بالنسبة لاي جسم موجود عليها او خارجها. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static subject. Its title, the center of gravity. My dear student, what is the center of gravity? Definition. The center of gravity of a raised body is a unique point in the space. Remember, my dear student, the center of gravity of a raised body is a unique point in the space, except the center of the earth. The line of action of each weight pass through it, and it is fixed whatever the position of the body change with respect to the surface of the earth. The center of gravity of raised body denoted by G. Look at, my dear student, important remark. Number 1, the line of the action of weight of raised body pass through its center of gravity and the center of the earth. Remember, very important remark. To understand the center of gravity, you must be know important remarks. The first remark, number 1, line of action of weight of raised body passes through its center of gravity and the center of the earth. Number 2, the center of gravity, my dear student, of a raised body is a fixed point with respect to the body, but it is not necessary that it is at one of its particles. Remember, my dear student, center of gravity of a raised body is a fixed point with respect to the body, but it is not necessary that it is at one of its particles. Position vector of the center of gravity of raised body respect to the origin point. My dear student, let W1, W2, 2Wn, weight of particles forming a raised body, R1, R2, 2Rn, position vectors of these particles with respect to the origin. Then position vector, its symbol Rg, to the center of gravity of raised body about the origin is determined by the relation Rg equals what? W1 R1 plus W2 R2 plus 2Wn Rn over W1 plus W2 2Wn. This number 1. We can replace W1 equals M1G, also W2 M2G, 2Wn MNG. Therefore, my dear student, M1, M2, Mn are mass of particle forming a raised body by substituting in equation 1. We deduce that dividing the numerator and denominator by G, gravity force. Therefore, M1R1 plus M2R2 plus MNRN over M1 plus M2 to Mn. The previous vector relation can be written in terms of components in direction, orthogonal coordinate axis OX direction and OY direction to get the following. XG equals what? M1x1, M2x2 to MNxn over M1 plus M2 to Mn. Also YG, M1y1 plus M2y2 to MNyn over M1 plus M2 to Mn. Example. Two bodies, mass of each 6 kilogram, 12 kilogram, and the distance between them is 90 centimeter. Remember, my dear student, we have two bodies, 6 kilogram, 12 kilogram, and its distance between them 90 centimeter. What is the required? Find the center of gravity of the two bodies with respect to the body 6 kilogram. My dear student, we have two bodies. The first body, its weight 6 kilogram or its mass 6 kilogram. The second body 12 kilogram. Distance between them 20. What is the required, my dear student? What is the center of gravity? There is a fixed point between the two bodies. What is the coordinate of the center of gravity? We know that the center of gravity is a fixed point, xg and yg. What is the xg? Equals m1 x1 plus m2 x2 over m1 plus m2. Also, we find yg by substitution about the relation m1 y1 plus m2 y2 over m1 plus m2. At the first, my dear student, we can determine x1 y1 and x2 y2. My dear student, look at the following solution. Look at, my dear student. We know that we have two bodies. The distance between them 90 centimeters. The first body is 6 kilogram, the second body 12 kilogram. We know that, or we take the first body, its mass 6 kilogram is origin point, and they make two axes, OX axis and OY axis. The first body, its position vector 0, 0, 0, 0, but the second 12 is 90 and 0. Look at the line joins the center of gravity of two bodies lie on x-axis, and the center of gravity of the mass 6 kilogram lies on origin point 0, 0. The center of gravity of the mass 12 kilogram lies at a point A 90 centimeter at x coordinate, 0 y coordinate. xg m1 x1 plus m2 x2 over m1 plus m2. By substitution about m1 x1 6 times 0 plus m2 12 times 90 over sum of two mass 6 plus 12, answer is 60 centimeter. yg m1 y1 plus m2 y2 over m1 plus m2, answer is 0 centimeter. Then, my dear student, Center of gravity at G, its coordinate 60, 0. The center of gravity as a distance 6 centimeter from the first body 6 kilogram. Remember, my dear student, the first is 6 kilogram, the second is 12 kilogram. The center of gravity from the first body as a distance 6 centimeter from the first body. Look at, my dear student, important remarks. Center of gravity of two particles where the distance between their center of gravity is constant L. The center of gravity of two particles where the distance between their center of gravity is constant L lies on the line segment joins them and divided its length by inverse ratio to their mass. Very important remark. Now we are translate to another example. My dear student, ABC is a triangle. AB 6 centimeter, BC 8 centimeter, CA equals 10 centimeter. What to deduce? X and certain this triangle is right angle triangle at B. Why? Because CA square equals AB square plus BC square. D and E are midpoints of AB and AC. Then 3 equal mass, each as M, are placed at B, D, and E. Find the center of gravity of this mass. My dear student, then 3 equal mass, each one is M, are placed at B, D, and E. What is the required? Find the center of gravity of this mass. Solution. Look at triangle ABC. My dear student, the point A, its coordinate 0, 6. Point B, origin point 0, 0. Point C, its coordinate 8, 0. Remember, my dear student, AB equals 6, BC equals 8, CA equals what? Equals 10. My dear student, look at midpoint D. D is midpoint of AB. Also M, B, and A. Look at, my dear student, midpoint. How to find the point D? Sum of x1 plus x2 over 2, y1 plus y1, y1 plus y2 over 2. Coordinate of point D, 0, 3. Understand, my dear student? Look at C square equals 100 by using Pythagoras theorem. Therefore, CA equals 10. ABC right angle triangle at B. My dear student, let BX, BY, B2 orthogonal and B is origin point. Point A 0, 6, point C 8, 0, point D 0, 3, point E 4, 3. It's better to form the following table to represent the mass and coordinate of each. My dear student, look at, we form table. This table has mass, x coordinate, y coordinate. We have 3 mass are equal at B and D and E, each one M. What is the coordinate of point B? 0, 0. What is the coordinate of point D? 0, 3. What is the coordinate of point E? 4, 3. Then we deduce that by using the table coordinates of the center of mass of the system. xg equals what? X and student, m1 x1 plus m2 x2 plus m3 x3 over sum of 3 mass. Answer is 4m over 3m equals 4 over 3 centimeter. By using same method, yg equals m times 0 plus m times 3 plus m times 3 equals 6m over 3m equals 2 coordinate. Then the center of gravity 4 over 3 and 2. Another example. Look at my dear student. ABC is an equilateral triangle. Its side length 12 centimeter. Mass of magnitude 3, 4, 5 gram are placed at its vertices A, B, C respectively. Determine the center of gravity of the system. Look at the solution. My dear student, we have A, B, C and 3 forces or 3 mass at 3 versus 3 gram at A, 4 gram at B, 5 gram at C. Remember, my dear student, if we have ABC equilateral, then the height equals 6 root 3 if its length 12 centimeter. We let Bx, By two orthogonal as shown in the figure. Consider B is the origin point, 0, 0. B, its origin point, 0, 0. Point C, 12, 0. Point A, 6 and 6 root 3. My dear student, we have ABC is an equilateral triangle. Its side length 12. How to find the height of equilateral triangle? By using, we know that, my dear student, each height perpendicular and bisect the base. Measure angle C equals 60, then the height equals length sine 60. Sine 60 root 3 over 2 times 12, the height equals 6 root 3. Then the point D, its coordinate 6, 6 root 3. My dear student, we have the table for mass and the coordinates will be as follows. We have mass at A3, at B4, at C5. Coordinate of X, coordinate at A6, at B0, at C12. Coordinates of Y at A6 root 3, at B0, at C0. How to find the center of gravity, my dear student? Excellent student. We applied the rule. Xg m1 x1 plus m2 x2 plus m3 x3 over sum of 3 mass. 3 times 6 plus 4 times 0 plus 5 times 12 over 3 plus 4 plus 5. Look at xg. Coordinate of the center xg 3 times 6 plus 4 times 0 plus 5 times 12 over sum of 3 mass. Answer is xg 78 over 12 or 13 over 2, 5, 6.5. yg by the same method my dear student, 3 times 6 root 3 plus 4 times 0 plus 5 times 0 over sum of 3 mass. Therefore, answer is YG 3 root 3 over 2. This is coordinate of the center of gravity 13 over 2 and 3 root 3 over 2. Respect to the point B. Now we are translate to another example. My dear student, ABCD is square of side lengths 10 centimeter. Masses of magnitude 12, 8, 6, 4 grams are fixed at its vertices A, B, C, and D respectively. And the mass 20 gram is fixed as a midpoint of AB. Determine the center of gravity of the system. My dear student, the required how to determine the center of gravity of the system. We have square and 4 mass act on 4 vertices. My dear student, the required how to determine the center of gravity of the system. Solution. Let Cx, Cy are 2 orthogonal axes in the figure, then form the table for mass and coordinate. My dear student, look at the figure. We take the point C as origin point, and Cx, Cy is x-axis, y-axis. What is the length of side? 10 centimeter. How many forces we have? How many mass? We have 4 mass at 4 vertices. Therefore, my dear student, we determine the coordinate of each point at C, at B, at A, at D, and midpoint of AB. Look at my dear student. We form the table. We have 5 mass at A, B, C, D, and E. At A, 12 gram, at B, 8, at C, 6, at D, 4, at E, 20 gram. Coordinate of X at A, 10, at B, 10, at C, 0, at D, 0, at E, 10. Coordinates of Y, 10 at A, 0 at B, 0 at C, 10 at D, 5 at E. Remember, my dear student, we take the point C is origin point. Then, my dear student, the center of gravity of the system xg by using the rule m1 times x1 12 times 10 plus 8 times 10 plus 6 times 0 plus 4 times 0 plus 20 times 10 over 12 plus 8 plus 6 plus 4 plus 20 to find the coordinate of xg equals what? Equals 8 centimeters. By using the same method, find yg. 12 times 10 plus 8 times 0 plus 6 times 0 plus 4 times 10 plus 20 times 5 over sum of all mass yg, my dear student, equals 5.2 centimeter. Then, how to determine the center of gravity by using xg, yg? The center of gravity is 8 and 8.5 is back to 2 point C. My dear student, at the first we determine the origin point is C, 0, 0, then the center of gravity is back to the point C, 8, 5.2. My dear student, we know that the center of gravity of the square, which 4 mass act at 4 vertices. At the first, we determine the origin point. In the previous example, we determine the point C is the origin point, 0, 0. And we determine the mass of each vertex. After that, we determine the coordinate of each point. By using the rule xg equals m1 x1, we have 5 mass, m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus m5 x5 over what? Sum of all mass. Maybe 4 or 5 mass are equal or are different. The rule sum of all mass. This is coordinate of xg. After that, we find the value of yg. yg m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 plus m5 y5. After that, divided sum of all mass to find the value of coordinates yg. Then we determine the center of gravity respect to the point C. This point, my dear student, you can determine someone determine another point. That is true. Someone determines the third point. But when determine the origin point to find the center of gravity, you say the center of gravity with respect to the point which we take it. Remember, my dear student? Maybe another student take the point B as the origin point. After that, determine the coordinate of B, 0, 0. And when find the center of gravity, you say the center of gravity respect to the point B. Maybe someone take point A, and also then, my dear student, we know that the center of gravity, we determine the origin point to find the center of gravity 4 mass or 3 mass or any mass act on A, B, C, and D vertices of the square. My dear student, this lesson is very important in our life. How to determine the center of gravity of each body respect to the earth. This lesson is very important lessons in our life. My dear student, I am very happy to spend such time with you. Thank you.